Welcome to this video on rate of change in linear, quadratic, and exponential functions. By the end of this video, you should be able to calculate the rate of change for any of the three functions, identify the functions, and determine whether there's a variable or constant rate of change. So, one thing we want to remember is rate of change is slope. They're the same thing. When we're talking about a line, our rate of change has a constant rate of change. So when we graph a line, we usually start at the y-intercept and then we'll count our slope and we'll count the same amount each time and plot our points and then draw our line. So that's what we mean. Every time we count to the next point with using our slope, it's the same number every single time. It doesn't matter what 2 points I pick, I'll get the same slope. For quadratic and exponential functions, however, because their graphs curve, you have a variable rate of change. So it depends on which 2 points you pick. For example, if I have a quadratic parabola here, okay, if I pick this point and this point to get a slope, I don't know the numbers, but I know my slope will be a negative number. But if I pick this point and this point, I don't know the numbers, but I know I'm going to end up with a positive slope. So it depends on where I'm asking the slope is going to change because of this curve situation. So it's a variable rate of change. Remember, when we want to calculate slope, we're going to use this formula. y2 minus y1 divided by x2 minus x1. Because there's negative signs in the formulas, you have to remember when you plug in the second number, the sign of that number is going to change opposite. All right, so let's go ahead and give a couple of these a try. We're going to be using Desmos, so you'll probably want to have that open with you. So before we start, let's look at this equation and identify as linear, quadratic, or exponential. The x is in the exponent, which makes this exponential. So go ahead and pause the video and put this into Desmos, and I'll tell you what to do from there. Now that the equation, as you can see, it is an exponential function. It grows rapidly as we move from left to right. We can kind of rearrange this. So what our notes are asking us is we want to know the slope between where an x value is 0 and an x value is 3. So this is really two different points, one where the x value is 0 and one where the x value is 3. What we're going to do is we're going to use Desmos to help us get the rest of the information, the y values, because we need those in order to be able to calculate our slope. So in Desmos, my equation is in, I'm going to touch the settings wheel, and I'm going to pick the table of values. So I needed where x was 0. When x is 0 for this equation, my y value is 4. So I'm going to write that next to the 0 to make the point. And we also want to know where x is 3. Notice 3 is not on here, but if I click into this last section and type in the 3, it will give me my y value there is 219. So let's go back and look at our notes. We have our 2 points now. So now we're going to use our formula to solve for the slope. This is y minus y. So the order in which you subtract doesn't matter as long as you go in the same order for the second point. So if I say 219 minus 4 divided by, now I say x minus x here, because I started with 219, I got to start back over in the same point and start with 3 minus 0. 219 minus 4 is 215. 3 minus 0 is 3. And this fraction will not reduce. That's as simplified as it can get. This is actually our slope. So if we wanted to plot points on that slope, that says rise 215 and then run 3. Remember, exponentials grow very quickly. They can be very steep, and that's why that's such a steep slope like that. All right, let's try this again with our next equation. So looking at our next equation, I notice that the x, the highest exponent, the largest exponent is a 2. When the largest exponent is 2, that means your graph is going to be a quadratic. So let's pause and put this into Desmos. All right, so I've put the equation into Desmos, and you can see the parabola. It is in fact a quadratic. So we're going to use our table of values just like we did before. Click on your settings wheel and choose the table, and it gives you the table of values for this actual function. Okay, so what are we looking for here? We're looking for when x is -2 and when x is 1. Okay, so let's go look at the table of values for that. When x is -2, y is 16. And when x is 1, y is 10. And that will give me my 2 points. And from there, we're going to use our slope formula like we did before. I'm going to say 10 minus 16 divided by, now it says x minus x, starting over in the same point I started with before. It's 1 minus, and then the second number, which happens to be -2. So we're going to deal with that in just a second. 10 minus 16 will give me -6. 1 minus -2 minus a negative turns positive. So I have here 1 plus 2, which gives me 3. And this will simplify down because -6 is divisible by 3, which gives me a slope of -2. All right, let's try this again. Go ahead and put your next equation into Desmos and come on back. All right, so we have 9x plus 3 equals y. The greatest exponent is a 1 on that x, which makes this linear. All right, so we're looking when x is 3, what's the y value? -3, and when x is +3, what is the y value? So we're going to go over and take a look at our table of values. Click the settings wheel, click on the table, and when x is -3, it's not on there, so I'm going to go to the bottom and type in -3, and that gives me -24. And when x is +3, your y value there is going to be 30. So now we have 2 points to work with, -3, -24, and 330. I'm going to set it up just like we've been doing. Y minus the second y divided by x minus the second x. Okay, so we end up with 30 minus -4 minus a negative turns positive, which gives us a 54. 3 minus -3 turns this into a positive, so now we have 3 plus 3, which is 6. And 54 divided by 6 is 9. Now if we take a look back, all the way back to the equation, remember this equation is in slope-intercept form, and that number right in front of the variable is always the slope on a line. And so it didn't matter what 2 points I picked, I'm going to get 9 out of it. For this line, the slope is the slope because it's constant. It doesn't matter what 2 points you pick, it's always going to be whatever the slope originally was. It's not changing ever. So let's take a look at our last one. Our last one says y equals 1/2 x plus 6, and over this particular interval. When I look at this, I'm trying to decide linear, quadratic, or exponential. I notice on my variable x, there's the greatest exponent that I have is a 1. When your greatest exponent is a 1, that means this is linear. So I learned a lesson over here, and that is if I have a linear equation, the slope is the slope is the slope. It's not going to change. And this equation is in slope-intercept form. And there's your slope right here. It doesn't matter if I can recalculate with these points, but no matter what, my slope is going to be 1/2. When you have a linear equation and you know what the m value is because it's in slope-intercept form, that's your slope. It doesn't matter which 2 points I'm asking between. All right, let's move on. What if we have a graph? So they're a little small, so we have to look carefully. So now I have a graph. This is going to be quadratic because it is a parabola. And I'm asking over the interval -4 to -2. So these are our x values. So I'm going to go where x is -4, and I'm going to follow it until I hit the graph which is right here. Actually, I think it's down one more. There we go. This is going to be at -4, -8. And where x is -2, that's our x-intercept right there. -2, 0. So we're naming the point. If the x value is -4, what does the rest of the point have to be on the graph? So now we have 2 points, and I'm going to use my formula. I'm going to say y minus y, so I'm going to say -8 minus 0, divided by x minus x, so it's -4 minus -2. And I get -8 minus 0 stays -8. -4 plus 2 becomes -2, and -8 divided by -2 is a positive 4. Another way we can look at this is we can count between these 2 points. So from here we can go 1, 2, 3, 4, 5, 6, 7, 8. So I rose 8 and I ran 2 to get to the second point. 8 and 2, and that would simplify to 4. Let's try our next one. We have an exponential function here. This one's a decay. It's dropping as it goes from left to right. So exponential function. And we want to know between the x values -2 and -1. So when x is -2, the y value looks like it's hitting right there at 5. And when x is -1, it's going to be hitting right here at -1, 1. Okay, now that I have 2 points, I can calculate my slope like I was before. And I'm going to say y minus y, so 1 minus 5, divided by x minus x, so -1 minus -2. -1 minus 5 gives me -4. -1 plus 2 gives me 1 for a slope of -4. And I'm going to take a look. To get from this point to this point, I'm going to go down 4 and right 1, which gives me a slope of -4. So we can count between the points if it's easier. For our last one, this is a straight line, making this linear. Now I'm wanting to know between these two x values. So if x is -8, my y value there is -6. So we have -8, -6. And if x is -4, we're right there on the x-intercept at 0. So I'm going to say y minus y, so -6 minus 0, divided by x minus x, -8 minus -4. -6 minus 0 is -6. -8 minus -4 becomes -8 plus 4, which is -4. Now 4 does not divide evenly into -6, but this will simplify. They can both be reduced. Both of these values can be reduced by 2, and because they're both negative, it becomes positive. So my slope here is 3/2. And if we looked between any 2 points, we're going to rise 3 and run 2, and that's our slope. It's going to be constant between every single point. All right, let's flip this over to finish it out. All right, let's take a look at these table of values. We need to identify as linear, quadratic, or exponential. So to do that, we want to see how our y values are changing. So to get from -2 to 1, I would have to add 3. From 1 to 4 is adding 3, and I'm noticing that this pattern is staying all the way true. So these are my first differences. That means this is going to be linear. Okay. Now, I have an x value of 1, so I'm going to find the x value of 1 in my table and see that the y value is 7. And then I have an x value of 2 with a y value of 10. Once I have my 2 points, I'm going to plug them into my slope formula. y minus y divided by x minus x equals 3 divided by 1, which is 3. So what I want to point out here is notice how the difference and the slope are the same. This common difference is the slope. So once you know this difference between these points, if it's a line, you know the slope of the line. Okay, it didn't matter which 2 points we picked because slope is constant for a line. So let's look at our next table of values. And if you look closely, you'll notice it's actually the same table of values. There's no difference. We can double check and we'll see that the first differences are a positive 3, making this linear. And it's asking for 2 different points, but it actually doesn't matter because this difference is the slope because it's a line. So your slope here is going to equal 3, even without calculating, because that's how it is for a line. Everything else you would have to calculate, but lines are constant. Let's take a look at our last example. Looking at my pattern, I'm noticing I'm not adding, and look how fast the y values are getting bigger, but the x's are only increasing by 1 each time. So I'm thinking exponential, so I'm going to look for a common multiplication pattern, and I'm noticing each time that this is multiplying by 3. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So I know because of a common multiplication pattern, this is an exponential. So we cannot do any sort of cheat. This isn't our slope because this is an exponential. That only works with our line. So we're going to look here. We want when x is 1, my y value there is 3. When x is 3, my y value there is 27. I have my 2 points, so I'm going to use my formula. Y minus y divided by x minus x. Now 27 minus 3 is going to be 24. 3 minus 1 is 2. This will simplify to 12. All right, hopefully that was helpful. Let me know if you have any questions. I'll see you in class.